Ionut Ionita. You can call me also John. I'm an OpenSIPS developer for almost 2 years now. Okay, and let's start. Well, first of all, why we changed all the SIP capture, engine? First of all, our SIP capture module wasn't compatible anymore with HOMER, so we had to change a lot of things there. Also, we wanted all the connection between the SIP trace and the SIP capture module to be asynchronous. So for that we implemented a new module called ProtoHep, which handles all the sending and the receiving. Also, we wanted HOMER 5 came with a new protocol called HEP version 3. We have to implement that also. It supports both UDP and TCP. Before HEP version 1 and 2 supported only UDP. And we also did some cool stuff to handle HEP packets inside the OpenSIPS. And you can also capture packets different than SIP. You can have something else there. Now a few words about the ProtoHep module. It's a network layer module. It handles all the connections. It has the sending and the receiving functions, and also the packing and unpacking functions for HEP. We support HEP version 1, 2, and 3. And a new thing in our proto modules, you can define both TCP and UDP listeners. So you can, in the same time, receive also on UDP and TCP, and on the UDP interface, you can receive both all the 3 versions of HEP. So you can have also in the same time, on the same socket, you can receive 1, 2, or 3. Next, what we changed in the SIP trace module, we got rid of all the flags there. Everything is on demand, is based on the SIP trace module, the SIP trace function, along with the trace ID parameter, which I will explain to you later. The trace ID allows defining databases, HEP and SIP destinations. All these were separate parameters before. Now you can define all of them in a single parameter. If you want HEP, you have to include ProtoHep module. And also, what is new, before we had only message and dialog level tracing. Dialog was made with trace dialog, I think it was the function. Now we can go all in the SIP trace function, but we also have now transaction level tracing. You can do, if you have loaded the transaction module, it will catch the whole transaction, but if you don't have it, it will catch only the request, okay, and the internally generated replies from OpenSIPS. What is interesting about the trace ID, you can, every trace ID is identified by its name, and one trace ID can contain multiple tracing destinations. So with only one trace ID, you can do HEP, SIP, and database tracing. Also, you have the MI function called SIP trace. Before you control the global SIP trace with this function, now you can set the state for each trace ID, as I will show you later. The SIP capture module is now fully compliant with HOMER 5, and we have some new interesting parameters there. You've got the HEP route, in which you get the HEP packet, but the payload is not part. So there you can have anything, not only SIP. Also, since OpenSIPS 2.2, you can turn your the SIP capture module can turn OpenSIPS into a HEP proxy. So you can forward packets to many capture agents, agents based on the same logic as the transaction module does. Also, if in the web route, if you have packets different than SIP, you can capture them with the report capture functions, which doesn't has only network layer information, and there's nothing SIP related there. Another interesting thing is that SIP capture is now async, also report capture is async. And now I'm going to present you all that you can do have related in the SIP capture module. You can, for the version 3, as you probably heard yesterday, is chunk based, so you can modify the chunks, you can add chunks, you also can remove chunks and read them. Also, for the proxy mode, we've got the have relay function. There is also this script variable have version with which you can see what version of have the packet is. Since with UDP you can receive all the 3 versions of have. Also, we've got the have router. I told you a few things before here. So the payload is not parsed. You have to, if you want the message to be parsed, you call the function have resume SIP, and you will go in the main route, the request route or the reply route, depending on the message. Also, you've got, since you can have TCP and UDP listeners, you can read all the information about the socket on which you receive the message using the HaveNet variable. So you can, here you can access ports, you can access IP addresses, and the protocol TCP or UDP. Now let me show you how can we manage the trace IDs. Here is the basic OpenSIPS script. I have this trace ID. Anything that is included is from here. Anything that is new. So this is how trace ID looks like. You have here the name between square brackets, the name of the trace ID. Okay, here is the URI. From the URI, we can see what type of trace ID we define. So if it starts with HEP, as it is here, it's a HEP trace ID, HEP type 1. If it starts with SIP, it's a SIP trace ID, and we are only going to forward the message, not pack it with HEP. And anything else we'll treat as a database URI. And we'll try to parse it. Also, for the database type trace IDs, you can define the table name in which to save the data. And for HEP, you can define the version of the protocol you want the packets to be sent with, and the transport protocol. So here you can have TCP and UDP. So I'm going to show you how can you manage from with the MI, how can we manage the trace IDs. So I'm going to start OpenSIPS. Okay, so here we see all the trace IDs. Here we've got the type of the ID. Here we've got the name. You can see that we have 2 trace IDs with the same name. So if we will use this trace ID, we will have both with TCP and UDP. Here we've got the URI and the state of the trace ID. If we set off all without any parameter, we only set off, and we will see that the global SIP trace is off. So all these trace IDs will be turned off. This state here will not count. I'm gonna turn it on, and you can set. Okay. So now you can see this trace ID is off, all its URI, so it won't be any tracing, it won't be done. Now I'm going to show you a few scenarios. The first scenario is a basic capture agent scenario. We've got OpenSIPS here, which does a SIP trace, and another OpenSIPS, which is a capture agent and stores the data into the database. So let me explain what I defined here. I've got two listeners. This is for HEP for SIP packets, and this is for HEP. I've got one TCP and one UDP listener. For the moment, I will use only the UDP one. And here, I will use only the UDP trace ID for the moment. You also have to include proto-HEP module, for, as I said before. And what I changed in the OpenSIPS script, so this is the basic OpenSIPS script. What I changed here, on the initial invite, I did SIP trace for the trace ID with the name HEP ID, which you can see here. I use the D flag, which stands for dialog. Here we can have T for transactions and M for messages. But I'm going to use the D flag right now. And here is the old traced user, ADP, that was a global parameter. But now you can give it to the SIP trace function. I'm also tracing the registrations. Here, if you can see, I use the flag T, which stands for transactions. So now I'm going to start OpenSIPS here. Okay. Now let me explain the capture agent script. So what I do here, now I will do the simple SIP capture. I've got one UDP interface on which I will receive the messages. And for the moment, I do only SIP capture on both the requests and the replies. Okay. Now let me register everything. Let me register and we'll see anything in the database. So here you've got that registration, sorry for that. We've got the registration captured into the database. Okay, so here is the register. And here we have the reply. Now let the things a little bit more complicated to show you all the features, all the new features. So I told you before the HEP route. The HEP route can have the following values. If you set SIP, you will go to the main request or reply route. So we'll go here or here depending on the message, if it's a request or a reply. If we set none, we won't go through the script and we see a HEP packet. We will directly save it into the database. So we will basically do SIP capture internally and won't go through the script. And anything else, so we don't have SIP or none, will be considered as a route. So you have to define a route with that name. I'm going to use the HEP route now. So here I've got my route. Here I want to somehow fake message other than SIP. So I'm setting these two chunks. You can see all the chunks in the HEP protocol documentation. I've got it right here. No? Here. Okay, so I'm setting chunk B, which is the protocol type. You can see the protocol types over here. And the payload. to be different than zip. So I'm setting anything that is coming over the TCP interface. I'm going to set it to RTCP, and I'm going to say a fake payload. So imagine that this is not happening here. This is someone who sends us a packet with payload different than zip. Also, what I'm doing here, anything that's not version 3, I'm going to the main request route. Because in versions 1 and 2 we don't have chunks and we can't modify the packet in any way. Next, here I get the chunk, the payload, the protocol type. I'm getting it with have-get function, and I'm trying to see here if I've got zip. If I've got zip, I'm going to the main request or reply route. That's what this function is doing. So it automatically breaks the script execution. So if we call this function, anything that is here won't matter. Next, if I've got anything different than zip, I'm gonna call the report capture function, which will save the message into the database. Now let me show you the zip capture table and the report capture table to see the difference between them. So this is a report capture. I've named it RTCP capture. You can see that there is nothing zip related here. The data is only about the protocol itself. Whereas we've got zip capture table, which has more zip related data. So we see URIs, we see users here. Okay, now what I'm gonna do, in the tracing script, I'm going to use both TCP and UDP trace IDs for both on both interfaces. And let me see. Okay, so I also need to have a TCP listener. Let me start. Okay, here I have both listeners now. Oops, sorry for that. Oh, forgot one on this. So, okay, started. Let me, I have a few scripts for cleaning all zip capture and RTCP capture tables. And now I'm going to register again. If we look in the zip capture table, we have the same messages that I showed you before, but in the RTCP capture, I've got the message with the values that I said before. So we've got the payload here, okay, and this is the protocol type. For the index for RTCP is 5. Now the next scenario I would like to show you is how you can turn OpenSIPs into a proxy. So here we have a zip capture that will be the proxy, and here we've got two capture agents. So it's the same scenario as before, but now we've got a proxy. The dispatching, the routing I'm gonna do is based on the dispatcher module. In the dispatcher module, I've got this database, this table, which contains two destinations, the port 6062 and 6063. So the script looks like this. We won't use the head route anymore, since we don't need it. By default, I forgot to tell you it's zip, of course. We go through the zip routes. So we are going to use this head proxy route. Okay. Here I also put you an example how you can add your custom chunks into the head packet. So we've got this vendor ID, and this is the payload of this chunk. For custom chunks, for your own defined chunks, you have to provide the data type, because we can figure out internally what data type is there. So both when setting and when reading it, you have to specify the type. This is the chunk ID. Every head chunk, as I showed you before, has an ID. I put 51, it doesn't have any meaning. Next I'm going to do, I'm going to select a destination with the dispatcher module from these two. Okay, so the hashing is being made based on the call ID. This what this 0 means. The hash is gonna be made over the call ID. Next I'm gonna call the help relay function. So as I told you, the relaying is done based on the request query or the destination query. We arrive basically is the same logic that the T relay applies. Here I've got the two capture agents, these ones, okay? So they do nothing complicated, they only receive the message and save it into the database. Basically what I did before with the other capture agents. Let me start them. It might take a while. Okay, this one started. Don't get confused by the name, it's not an agent anymore, it's a proxy. So here, now I will use only the UDP trace ID, since the TCP one doesn't make any sense to it. Okay, let me do a click on the tables. Also, I put a log message here to see on which node we capture the message. So I'm gonna register. Okay, we see we received on node 2. If I try, okay, now we received on node 1. So I'm doing this balancing between these two capture agents. I'm saving it in the same database, so they will all be in the same table, of course. Now the final scenario that I would like to show you is how can you integrate OpenSIPS with HOMER. So basically, HOMER it has its own database, so we have to save everything that is captured. We have to save there. In the same scenario, I will also keep the proxy, and here we will have two such instances. So we'll use these two nodes I showed you before. Now let me show you the HOMER table database. I will only use they have, sorry for that. They have three databases. Here we have nothing to do. But this one is where we save our C packet, SIP or any other thing. And here is the statistic. This is a more is making a much more complicated script, which Alexander provided for us. You can find it on their GitHub repository. It's over here. It's a little bit more complicated, but this is doing all those catchy graphics, which will help you in debugging. Now I'm populating only the HOMER data, which has these they have these tables. They are rotating them every day. So here we see a prefix with the day, today is the 11th, so this table will be used. They have capture tables for calls, registration, and for other messages. Here we see the table that you can use for other messages. Let me Okay, so what are we doing here? This is the chunk that I said earlier. I showed you here. So this is this chunk. I'm gonna read it, and we will do the SIP capture. We'll look if the message is a register. We'll save it in the registration table. We have, since this version, we have this format, which is the same as strf time, standard C function, or if you use the function time from bash, this is the year, this is the month, and this is the day. You can use anything that's in strf time. So, okay. Now I'm gonna start the agents. Okay, so we started. I'm gonna start the proxy, and of course OpenSIPS. Let me register one more time. About the installation of HOMER, I used their quick install guide, which is over here. They said yesterday that it takes 5 minutes. I think for me it took like 3. It's very easy to install. So I have it installed over here. I'm going to sign in, and I'm going to look into the registration table. Let's see here. We have to set the date, the time for which we want to see the capture. And now, sorry, that. Let me check. Oh. Of course, sorry for that. I forgot to change the database. I used OpenSIPS database and not the HOMER database. Sorry for that. Okay. Now let me start again. Okay, everything is in its place. Let me register. Okay, so node 1. I also want something on node 2. Okay, I got something. This is the chunk I said before. You can see it here. Also, what I forgot to mention, each capture node can have its own ID. So I put here HOMER 1, and here I got HOMER 2. So we can see them differently on the platform. Okay, here we got the messages. You can see over here. Let me get that. Okay, so here we got the ID of the node which captured the message. You can see, and if we click on the call ID, you can see the message flow exactly. Also, if you use Alexander script, you will have also these reports here and logs and everything. But I only save the packet into the database. Now I also want to show you a call. I've got this CPP script which does the registration. And after that it waits for calls. So I'm gonna start it. Okay, I already have it in link here. Okay, this one. flows. So now we have to look in the calls table. Now this is a call I've made. You can see here two messages of each type, because we once capture them when they enter OpenSIPS and once when they leave OpenSIPS. And here we've got the whole message flow. So this is about it. Thank you for listening, and if you have any questions. Yeah?
It's not a question, but great job. It's fantastic.
Hey, some questions. It's a great job? Yes.
I couldn't hold myself, sorry.
No other questions? Come on, people, reach.
Just a comment I would like to tell.
Okay.
Is comments is okay?
Oh, you've got something to add.
Yeah.
Please, by all means.
Because yesterday Flavio explained us about capturing from cloud and big data. But exactly your implementation of HAP proxy, it's exactly what it's developed for. Because in this HAP proxy, you can it has many instances of MySQL or any other databases, and collect without any limits messages and store it to the database. So it's, you should not use Elasticsearch. It's only HAP proxy based on OpenShift and MySQL. Sorry for these comments.
It's okay.
Does anybody have any questions on those comments? Okay, John, thank you. Everybody else can say anything.